Hi, math lovers. Welcome to notes number 135. I'm on lesson 9.3. Today's problems are going to have more than two variables. Really exciting. So I'm gone to your book. I'm on page 686. Take a moment and take a look at that problem. You probably want to pause the video and think about it. This is definitely one that your geometry teacher would have loved last year. Or this year if you're in geometry this year. So I'm staring at this problem. It's a triangle. There are some markings in your textbook, but I do not want you to think those markings are because of equivalent angle measures. Those markings are only just to show you which angles they are. So clearly this is angle X, this is angle Z, this angle is Y, this angle here is 2x minus 7, and this angle here is 2x plus 7. So let's go ahead and come up with some equations that we can use to solve this. Straight up, I'm going to go with x plus y plus z equals 180. Oops, that's a funny looking 180, because the sum of the interior angles of a triangle are equal to 180. I'm also thinking about this angle right here. I'm thinking that z plus 2x plus 7 is equal to 180. And I'm also thinking about this angle here where I have y plus 2x minus 7 equals 180. Okay, so I have three equations. Awesome. Good for me. Got a system of equations. Now all I have to do is solve it. Well, this is where I have to put on my thinking cap. All right, so stop and think about what you know. Well, this is not, oh gosh, messy pen. This is not lined up at all. It's not pretty. Let's go ahead and rewrite this in beautiful form. So our x's are lined up, my y's are lined up. This would be 2x plus z. And let's bring the 7 over. So that's 173. Okay, looking better already. And this last one, I have 2x plus y equals, and if I bring the 7 over, 187. All right, so this looks much better. I'm happier with my outcome. So I'm going to stare at this, see how I can work together. I don't know about you, but right away, these z's are jumping out at me, right? If I subtract these two equations, I wonder what would happen. So if I take this equation, x plus y plus z equals 180, and I take this equation and I'm going to multiply everything by -1. You can just go ahead if you want and you could subtract, but I'm so terrible with that. Look at that. I lose negative signs all the time. So it would be negative x plus y equals 7. Oh, you know what I'm thinking? Oh, this looks like a great substitution problem. Look at that. I know what y equals. Y equals x plus 7. Is there another equation that just has a y in it? Look at that. So if I took this equation, 2x plus y equals 187, and I substitute that right in for my y, oh, gorgeous. So it's 2x plus, now instead of y, I'm going to put in x plus 7 equals 187. We'll clean that up. Let's make it 3x plus 7 equals 187. Subtract that. So 3x is equal to 180. X is equal to 60. Bam, we got it, right? X is equal to 60 degrees. Beautiful. So my job now is to find the other three angles, or I'm sorry, the other two angle measures, the x angle and the y angle. All right, so let's see. If I know that x is 60, can I go ahead and use this? Y equals 60 plus 7, and therefore y is equal to 67. I have that. I have x. I have y. Now I'm left with z. Oh, this is fabulous. So I've got x plus y plus z is equal to 180. I know x is 60, y is 67, equals 180. So straight away, I'm going to take 180, I'm going to subtract 60, I'm going to subtract 67, and z is going to equal 53. All right. Now I want to be sure that I have the correct answer here. So what I would do personally is I would plug these angle measures back in up here, make sure that they work in all of them, because I always like to get the right answer. All right. So my friends, there is no special algorithm to just solving a equation with more than two variables. But what usually works for me is if I isolate two equations and get rid of one variable. So like I did here, I isolated these two equations and I got rid of the z. Then I used my answer to plug it into another equation. That would work. Now, if I did not have such an easy time with it, maybe I would have taken these first two equations and gotten rid of the z, and then taken the second two equations and also gotten rid of the z. That would work nicely for me. But you'll see all that fun stuff in your problem set. Have fun.